Hello everyone. Let's continue with our work and energy worksheet. I'm at energy part 1, question 10. So question 10 is a simple calculation of GPE. So again, reminder to you to start writing the formula and then the substitution and then finally the final answer with the correct units. So, round up to three significant figure. So in this question, the mass, gravitational field strength is given, but you've got to be careful because the distance is given in centimeters. So you need to convert it to meters here, and you can get a final answer of 4.4 joules. Question 11 require you to understand principles of conservation of energy. So what it means is that energy cannot be created or destroyed. Now, but they can be converted from one form to another, or they can be transferred from one body to another. So in this case, the energy that is given to the fan, the energy that's given to the fan is 500, the energy that's given to the fan is 500 joules. And the energy that comes out of the fan should also be 500 because energy cannot be destroyed, right? But if you look at it, the energy that comes out from the fan, because the fan will spin, you will take in the electrical energy, the motor will work, the fan will spin, and then you get 360 joules of kinetic energy. And of course, the spinning and so on, the motor gets heated up. So some heat is produced, so that's 100, but total is 460. So you have 500 coming in, and then you get 460 going out. So this doesn't seem right, because we have a missing 40 joules of energy. So that's why the question asks, do you think all the energy conversions are shown? Your answer should be no. Not all energy conversions are shown because the input energy of 500 is not equal to the output energy of 460. So again, because the question asks you to explain, so you need to ask yourself, now, how do you explain the fact that the input and the output must be the same? So you have to use principles of conservation of energy to explain. So then it says energy cannot be created or destroyed. Hence, the amount of input and output must be the same. Now, in this case, just in case you're wondering, what happened to the 40 joules of energy? Well, some of the possible energy conversion could be the electrical energy converted to heat, because when the fan is operating, there's a bit of sound being produced. So it could be that energy being converted to sound, or perhaps the fan, if there is an indicator, then maybe a little bit of light. Okay, but this at least shows that there is something else. There is something else here that is not shown, because these two values are not the same. Okay, so to get full marks for this question, you need to state the principles of conservation of energy in your answer to justify your explanation. Question 12 is a calculation of kinetic energy. So mass is given, the speed is given. Just a word of caution. Now, when we say half mv squared, please take note, this v here is only the square for the speed. It is not to square your mv or not to square your half mv. So basically, it's half times, sorry, it's a bit messy here. Let me write again. So basically, it is half times your mass times square of your speed. So 20. So you are only squaring the speed. So be very careful when you're pressing your calculator, because this is when a lot of students will make mistake. And when you press the square wrongly, you end up squaring the whole thing. So you get 180,000 joules, but the question wants you to give your answer in kilojoules. So 1 kilo is 1,000. So I'm going to replace this 1,000 with a kilo. So 180 kilojoules. Question 13. The kinetic energy is given, the mass is given, and you're asked to calculate the speed. So again, write out the formula, put in your substitution. Be very careful. The mass is in grams, so you need to convert to kilogram. So this is a conversion to kilogram, and then the rest will be mathematics. You have to try out yourself, just to be careful, to make sure that the mathematical part is done correctly, because sometimes when you shift the values here and there, you may make a mistake. So if you've done it correctly, your answer should be 40 meters per second. Question 14. This is a question where the height of an object is given. So the height is 2 meters. The GPE is also given 0.6, and they ask for the weight. So once the GPE is given, we can write out the formula. GPE is GPE is mgh. Then we ask ourselves, if you look at the formula closely, I want you to remember this mg here, this mg here is the same as what you learned in the previous chapter on mass and weight. W equals to mg. It's the same mg. So instead of writing mg, I can write weight. So GPE is weight times height. So you know the GPE, you know the height, you can work out the weight easily, and do note this newtons and not kilograms. Question 16 is a basketball. The path is from A to F. The question asks for the gain in GPE. So just a little thing to note here. Now, if the question asks you to calculate GPE, I think by now we all should be very familiar. The formula is mgh. So you just take the mass multiplied by gravitational field strength multiplied by how high the object is above the ground, right? But when the question asks for the gain in GPE, the gain, then of course you can still use the same formula, but now the h will be the gain in height. That means the object would have moved from one position to the next. So what is the increase in the height? So like what you can see from here, the gain in GPE is mg. So h is the gain in height. How much higher is it now? So from A to F, this is 1.7 meters. So it was 1.5. So you subtract, and then your answer will be 3 joules. Of course, you can also calculate the GPE at A, calculate the GPE at F, and then you minus. It's fine. Just a little more work on your part. But that is a method that can be used as well. Then suggest a path in which the ball loses kinetic energy. So again, when an object is being moved, when the object is moving upwards on its own, it will actually move slower and slower. So if you look at the diagram, this part here, it is moving upwards, so the speed will slow down. So as long as the speed slows down, when your V decreases, your KE decreases as well. And so therefore, actually there are many answers. You can say A to B, B to C, or C to D, or A to C, or B to D. As long as you're talking about this path over here, your answer will be correct. Question 16 is on pendulum. The question asks, what is the energy conversion from A to C? So again, remember, as long as the height decreases, your GPE will decrease. As long as your speed decreases, your KE decreases. The same apply for the increasing as well. So from A to C, you will notice that the ball is going lower and lower and lower. So I know that the GPE, because the ball is going lower, the GPE will decrease. At the same time, anytime you let something drop from a height, whether you tie it with a string or not, as long as it's dropping from a height, the KE, it will actually increase in speed. So the KE will increase. All right. Right. So for positions, So for positions A to C, when it's moving downwards, as you can see, your GPE is becoming lesser and lesser, while your KE becomes more and more. So that is because your GPE has been converted to KE. Okay, so the answer should be GPE to KE. Please write it in full. What about from C to E? Well, again, you can see that the bob of the pendulum is moving higher and higher. So anything that's moving higher, the GPE will increase. And again, an object that's moving higher and higher on its own, it will start to slow down. So the KE will be smaller. In fact, it will slow down so much that at the end, at this point here, the speed is actually zero meters per second. Right. So therefore, the energy conversion is KE to GPE. Okay. And the question asks, which position has the maximum KE? So you have to ask yourself, when the pendulum is swinging, which position is it the fastest? And the answer should be C. There are quite a number of students who will say that it's A, but actually at point A, it is not moving. It just start to move. So it will actually moves faster and faster and faster and faster. And the fastest is actually at C. Then it starts to slow down again. Okay, so position C is the answer. The maximum GPE, that means the highest point. From this diagram, I can see that A is the highest point, not really E. E is slightly lower than A. So A should be the answer. Okay, there are some explanation here that you can pause the video to read if you wish. And then the next question. This question says that if a toy car has a speed of 2, it's moving at the speed of 2. So what must the speed be in order to double its kinetic energy? Now, please do not just look at 2 and you say that, oh, to double the kinetic energy, that means I must double the speed. The reason is because if you look at the formula, it is not something that's so straightforward, because KE is half mv squared. So if you double the mass, yes, you double the KE, that's right. But because this one has a square over here, so it is not so straightforward. In fact, when you double the speed, you get actually more than double the KE. So how do I approach this question? I'll write the formula first, and the speed is 2, so I substitute 2, and then I will get 2m. So 2m is the original. This is the original kinetic energy. And what am I supposed to do? I'm supposed to double this kinetic energy. I'm supposed to get double this amount. So therefore, again, I quote the formula. So now I'm supposed to double the KE. So instead of 2m, I'm supposed to get 4m. Then it's half. It's still half. The mass is still m, but I don't know what this v is. So I'm going to just put v squared. And because there's an m and there's an m here, right? So I can cancel. And then maybe I just write the working over here first, some intermediate working, equals to half v squared. So v squared equals to 4 divided by half, which is 8. But I'm not finding v squared, I'm finding v, right? So square root of 8. And that's how I get 2.83 as the answer. Okay, right, let's move on. Oh no, so that's the last question, question 17. So you watch the next video for energy part 2. Okay, happy learning.